David Smith here with one more Flip Classroom math video. 3 tips before we start. You could turn on the captions and watch my words go by on the screen if that helps. You could also speed up the playback if you can get through the video faster and still comprehend. Lastly, you could pause video at any time and catch up on your notes. Today's lesson is on problem solving. We have 2 topics. We're going to talk about using angles of elevation and depression, and then we're going to use bearings, compass bearings. So first off, angles of elevation and depression. This is a fairly simple concept. I want to outline it out here with a little cartoon. Here's my dude. Here's a horizontal line. So he could be looking straight horizontal. Now if he looks up, say at a bird in the sky or the top of a tree, he's going to look up, and the angle from the horizontal to the direction that he's looking is called the angle of elevation. Makes sense. Elevation has this upward feeling to it. You're elevated. Your mood is elevated. That's up. Now, if he's standing on the top of a cliff and looking down at a house on the ground or something like that, then he's got an angle of depression, looking down. So that would be this angle in here. Now, depression is like down. You're down in the dumps. So looking down is an angle of depression. I want to draw your attention to this diagram. It's a fairly common problem or type of problem. Somebody standing on the top of a cliff looking down at something, or somebody is standing at the bottom looking up at something. So each of these people have different angles to think about. So first off, this person who's looking down at the boat, where's the angle of depression? Take a look at the diagram, mark that on your diagram, and then come back. So the angle of depression is right here. It's the angle downward from the horizontal. So that would be there. And I'm going to go ahead and mark that as theta. So that's our theta. Now I want you to look at this person who's on the sailboat and mark their angle of elevation because they're looking up at the person on the cliff. So here we go. We've got our angle of elevation right there. Now there's something else we can say in this diagram that will become important later. So study this and see if you can add another variable, particularly to this angle. All right, let's see how you did. This angle is also theta. It's the same angle, okay? Now, pause the video and think if you can find the reason why. If that's theta, so is that. This has to do with parallel lines. These 2 horizontals, the one up here and the one down there, they're parallel. Every horizontal line is parallel to every other horizontal line. So this line of sight, whether you're looking up or down, is cutting 2 parallel lines. And when you have parallel lines, the alternate interior angles are equal. So this angle equals that angle. So whatever you find for the angle of depression for someone above looking down at something, that's the same as the angle of elevation from someone down at that something looking up at the first person. Let's use this idea to do a word problem. So here's a person standing looking at the top of a tree, okay? They have a means to measure their angle of elevation. So we know that they're looking up at an angle of 28 degrees to the top of the tree. We've also measured how far away they are from the base, and that's 38 feet. Finally, we know that their eye level is 6 feet above the ground. So now you have enough information to find out how tall the tree is. So go ahead and do that calculation. All right, let's see how you did. So I'm looking at my triangle, and I'm thinking SOHCAHTOA trigonometry. We can assume that that's a 90 degrees angle. So sometimes in a word problem, you have to make that kind of an assumption. If you see a geometrical diagram and it's not marked as 90, then you can't. But in this problem, we couldn't really do it unless we knew that this was 90 degrees. So knowing that, knowing I have a right triangle, I'm thinking SOHCAHTOA. And so I'm standing at this angle, and I want to know the opposite side. That's going to help me find the height of the tree. And I know my adjacent side. That's my 38. So I can use tangent to set up a ratio and solve for this x. So that is tan 38 equals x, or tan 28 equals x over 38. That's my ratio. I rearranged it like this to show what x equals. I did my calculation in my calculator, and I got 20.2. Now, if you stop there, you miss something. The person's eye level is 6 feet above the ground. So you've got to add that 6 feet into the height here because we just found this distance. We didn't add this in. So our total height is 26.2, 3 sig figs. This little single quote mark represents feet. So you can use that for your units, or you could just write FT or feet. Let's do a word problem. This time, you're not being supplied a diagram. So for geometry, always, always, always draw a diagram. Or if you have a diagram in the book or in the problem that you're doing, copy it down in your notes and then add things to it, because almost always you will need to do that. So here's our problem. There's a person flying a kite on a string that's 46 meters long. So they're holding this string, the kite's up there in the air, and the string from them to the kite is 46 meters long. Their angle of elevation when looking up at the kite is 36 degrees. So they're looking up at 36 degrees to the kite. How high is the kite? So pause the video and make a geometrical diagram showing that situation. All right, here's my diagram. Person standing here on the ground, looking up at 36 degrees at the kite, which is over here, and the string is 46 meters long. Now, we have to make a couple assumptions in this problem because we haven't been given the information. I'm going to assume that that kite string is straight. Now, we know in reality that it's going to sag for sure. Gravity's going to pull down and it's going to dip down in the center and then climb back up to the kite. But we really can't do that problem unless we assume the kite string is straight. That's the first assumption. Second assumption, take a look at that diagram and figure out what we've done there. We've simplified something. Okay, check it out. We're not accounting for the fact that the person is standing above their eye level is above the ground. We don't have that information in the problem, so we can't account for it in our solution or our diagram. So we're just assuming that we're calculating the height from their eye level to the kite. So that's just a simplifying assumption. There is no way you can do that given what's here in the problem. So now I want you to pause the video, write a trigonometric equation, and solve for h. Okay, here's what I get. Sine 36 is h over 46. That's sine is opposite over hypotenuse. So h over 46, rearrange that. I've got h is 46 times sine 36. Do my math, I get 27.0 meters. It's actually 27.03, but I can't throw that last decimal in there and it doesn't round up to 0. So I need to say 27.0 meters. Let's talk about compass bearings. Now, a compass is just a little device that you hold in your hand and the arrow points north. And so you can use the compass to figure out what direction you're looking. So if the compass points north and you're looking, say, in the west, the compass is going to give you a reading that lets you know that you're actually looking west because north is that way. So here is my bearing grid. This is kind of like a coordinate grid, but instead of plotting points on here, we're basically talking about angles on here. So north is straight up, east is to the right, south is straight down, and west is to the left. Now here's how we talk about things. Let's say that you're looking in this direction, and this is 45 degrees, okay? So you're standing on the ground and you've turned a little bit to the east and now you're looking straight that way. We have two ways of saying what that bearing is. See, when you're looking in a direction and you think about that direction in relation to north, you speak of having a certain bearing. So two ways. One is north, 45 east. And that just means you're looking 45 degrees north towards the east. So you're away from north by 45 and it's in the direction of east. Now we also measure just all the way around in terms of 360. So this one is also just 45 degrees. Okay? So this one is more simple, but you're going to see this notation and you do need to understand how to do it. So let's look at another one. How about that one? This one is 60 degrees from the east. So go ahead, pause the video and write both of these notations for this bearing. All right, so we are 60 degrees south of east because we've gone towards south. We haven't gone towards north, we've gone towards south. So this is east 60 south. This is also 150 from the north because 90 would be east, and then we add another 60. So our bearing is also just 150 degrees. Let's do one more. 58 degrees in here. Go ahead and write that in both notations. All right, so the first notation is we are just 58 degrees to the west of north. So that's north 58 west. So that specifies that bearing. Now we also have a 360 way of doing that. So that would be 90 plus 90 plus 90. And then what's that? This would be 90 minus 58, okay? So that would give us 302 as our total. So what I did to make it kind of faster is I realized that going all the way around to north is 360, but I'm 58 degrees less than that. So I subtracted 58 from 360 to get 302. But you can go either way. 3 more quick little practice bearing problems. So I've listed 3 bearings here. I've got A with that measure, I've got C with that measure, and I've got B with that measure. Go ahead and pause the video and come up with both notations for each of these 3 bearings. Let's see how you did. So bearing A, 37 degrees north of east. So east 37 north. To find its absolute bearing, we would just subtract 37 from 90. East is 90, so less 37, our absolute bearing would be 53 degrees. Number B, we are west 16 south. So that's west 16 degrees south, and west is 3 90s. We have 90, 90, 90. So west is 270, and we're going to subtract our 16. So 270 minus 16, we have 254 degrees for bearing B. Bearing C, we are south. We are 21 degrees east of south. So that's south 21 degrees east. And so south is 180 degrees because that's 2 90s. And we're going to subtract our 21 to get 159. Here's a quick little one that's just a tad more challenging. Express the bearing 125 degrees in 2 different ways. Let's see how you did. So the first step, I think, is to make your diagram so that you can figure out what's going on. So I made my compass diagram, my bearing diagram. I took my 125. I realized that this is 35 past 90. So here's north, east is 90, so we're 35 more. So that's the first number that I can write on my bearing diagram. So that tells me that this bearing of 125 can be written as east 35 south, because that's what we're doing. We're 35 south of east. Now for the second one, I realized that if I know this angle, I could say south angle east, because I'm just starting in south and going towards the east. I know that both of these angles have to add up to 90, so 35 and 55 make 90, so that gives me 55 there, so I can do south 55 east as my second bearing. Let's do a couple bearing problems. So here you go. Another problem that has only words, so your first step is to draw a diagram to help you orientate to what you need to calculate. So here it is. A student runs 5 kilometers on a bearing of 120 degrees. How far south has she traveled? So go ahead, pause the video, and just make a diagram marking the relevant points, what you know and what you need to find. Here's my diagram. I've got my compass, marked all my compass points so that I'm orientated to what's going on. She starts at the center. You got to assume that because we're wanting to know how far south she has traveled. And she's running 5 kilometers, so that's that distance. And I have 30 degrees in there. I'm hoping that you can see why that's 30. Okay, it's 30 because the whole bearing is 120. So from the north, the bearing is 120. But what we've done is that means it's 30 degrees south of east. Because east is 90, we need to go 30 more to get to 120. So that gives us this angle in there. So if you haven't already done so, solve this equation. Using SOHCAHTOA, I realized that sine 30 is x over 5. So I wrote my equation there, I rearranged it to solve for x, I did my calculator work on that, and I got 2.5 kilometers. Now, that doesn't look like 3 sig figs, but that's right. Do you understand why? Okay, when you do this on your calculator, you get 2.5 full stop. There's no decimals. I'm not rounding. So there aren't 3 sig figs in this number. So you wouldn't add a 0 because that would imply that there was something out there that could have or could not have been rounded. So even though we require 3 sig figs, in this case the answer is just 2.5. One last bearing problem. This one a little bit more complicated. There's a crow and they're 6 miles east of their nest. He then flies 4 miles on this bearing, east 50 south. Okay, so flying 4 more miles. The question is, how far east of his nest is he now? So I want to break this down into 2 steps like we've been doing. Pause the video and make a diagram that you can label the parts that you have and then put a variable for the parts that you need. All right, let's see how you did. I didn't make a full compass bearing diagram. I just focused on the parts that I needed. So here is where I'm drawing my north arrow. Here is my east line. My bearing is 50 south of east. So I've drawn that 50 right in here. It's 50 degrees south of east. And then I've put my 4 on here because that's the distance that the crow flies on that bearing. So this distance is 4. I've also noted on my diagram that the nest is 6 miles to the east. I didn't actually put it on here, but it's 6 more miles to the east. So we're being asked, how far east of the nest is he now? So here, he's already 6 east. We just need to find out what this distance is, add it to 6, and that would be how far east the crow is after this flight. Okay, so if that makes sense to you, now I want you to pause the video and answer the question. Let's see how you did. So looking at my triangle with what I know and what I need to know, I realized that the cosine function is going to link up this side, which is adjacent to the angle, and my hypotenuse. Remember that my right angle is right there. So using cosine, I can write the following equation. Cosine 50 equals x over 4, which is adjacent over hypotenuse. Rearrange the equation, get out the calculator. X is 2.57 miles. So to get my distance east, remember, the nest is here, 6 miles away from the starting point. We've flown x more east, 2.57 more. So my total distance away from the nest in the eastern direction is now 8.57 miles. Now that you've watched the video, take a moment to write down any remaining questions so you can bring them to our next class. Also, remember that you can come back to this video, watch it again if you want to deepen your understanding or fill in any gaps. Lastly, if you enjoyed yourself, please click like or subscribe.